right, you guys, everybody's favorite stoichiometry, or the much cooler dimensional analysis question. Sean is riding his bicycle and the wheel goes around and around 3 times each second. So what I have here is I did 3 rotations for 1 second, right? And I know that 1 rotation is 2 pi radians, okay? And that's all I need to cancel out, because what I'm looking at for A is how many radians per second, right? So as long as I have radians per second, I'm good. So my green's going to cancel out, and my radians per second is what's going to be left over, right? So once again, I know it's turning 3 times. So I have 3 rotations, and that's my unit. I just put rotations, in 1 second. And I know that there are 2 pi radians, right? You could put radians there if you wanted to, radians, in 1 rotation of a circle, and my rotations cancel. So I get 6 pi radians per second. So that's my speed in radians per second, and that's what it was asking me for, okay? So then below, what I have is the diameter. Oh, son of a gun. The diameter of the bicycle wheel is 26 inches. So I made a little bit of a mistake in my setup. I'll fix that. It's not going to be 26 inches per rotation. I have to use that diameter of 26 to find the circumference, which is what it's going to be per rotation. So if my diameter is 26, the formula is cherry pie is delicious. So my circumference is just going to be pi times that diameter. So that's cool. So it's just going to be 26 pi inches per rotation, and my rotation is 2 pi, right? That's my radians, okay? So that was my original setup. Then I know my answer needs to be in feet per second. So I know I need to cancel out my inches to get feet, and I need to change my radians to seconds. So I know that there are 6 pi radians per 1 second, and there are 12 inches per 1 foot, right? So all I am left with after things cancel, my inches are going to cancel, my radians are going to cancel. What I'm going to be left with is feet per second, which is what it's asking for. So what can I do here? I know you just multiply all of your numerators. So 26 pi times 1 times 6 pi. But actually, before I do that, I'm going to make this smaller. I know 2 pi can go into 26 pi 13 times. So my numerator is just going to be 13 times 6 pi. That way I don't have to worry about squaring pi. And my denominator is going to be, and that's going to be my feet. My denominator is going to be 12 times 1 times 1, which is going to be 12, right? Let's see, I can cancel this out and make this 2, right? And 13 divided by 2 is what? Half of 13? 12? 6.5? Ha! So I have 6.5, that's a 0.5, 6.5 times pi, feet per second, feet per second. Now you can just multiply that out, which would be, I don't know, 20 something, 6.5 times. You could also just put all of that in the calculator, but I thought, why not just do some mental math? Times pi, 20.42 approximately is, so this is my perfect answer, or it's approximately 20.42 feet per second. That doesn't sound that far. That doesn't sound that fast, but it's fine. All right, sketch a graph of the unit circle, and you guys can use your unit circle, so how hard can this one be? And label the following angles and state the cosine, the sine, cosine, and tangent of each angle. Okay, so here's my unit circle. So let's draw my circle. I know this is half a pi, so pi divided by 2. This is a full pi. This is a pi and a half, which we call 3 pi over 2, because 3 divided by 2 is 1.5. This is 2 pi. And I know 45 degrees is pi over 4. It's a fourth of a pi. Or if this is half of a pi, then this is pi over 4. And pi over 3 is that going to be bigger? A third is going to be bigger than a fourth, so it's going to be pi over 3 here. But again, you have your unit circle, right? And then 3 pi is going to be the same as pi. 3 pi and pi are coterminal angles, right? Okay. Then state the sine, cosine, and tangent of each angle. So you guys are going to have that on your unit circle that you will have with you. If you don't have one, I would suggest you print one out before class tomorrow. So I'm not going to go over this other than I think I know pi over 4 by heart because the point at pi over 4 is the square root of 2 over 2, comma, square root of 2 over 2. So this is the cosine, right? This is the sine. The cosine and sine are both root pi over 2. The tangent is the cosine divided by the sine, or the sine divided by the cosine, actually one of those. Either way, the tangent is 1. It's the sine divided by the cosine, you guys. I don't know why I couldn't remember that off the top of my head. Cool? Cool, cool. Look, we're only halfway through this video. Solve each of the following equations for x is between. So all that means is it just wants an angle within one circle, right? From 0 to 2 pi. So one circle. That's all it's talking about there. So 2 cosine plus 1 equals 0. So if we subtract 1 from each side, we have 2 cosine x equals -1. Cosine of x equals -1/2. So on the circle, it's asking for what, and this 2 pi means we're probably going to be in radians. So where is the cosine of x? At what angle is the cosine of x -1/2? And I think I might have to look up a unit circle here. Or let's use our calculator, -1/2. Our calculator might not give us a great angle though, because it's going to give us a funky number. But let me make sure my mode is in radians. Okay, and then quit, and I'm going to do second cosine because I don't know the cosine. So second cosine of -0.5. Oh, and it isn't going to be good because it's going to give it to me multiplied out, right? So actually, let me change that to, degrees, mode, degrees. Okay, so let's try it again. 120 degrees, right, which is here. Which is, what is 120 degrees? 2 pi over 3? I think 2 pi divided by 3. Yes, I'm right. I went ahead, you guys, and found a unit circle, and at 120 degrees it is 2 pi over 3. Cool. Is there one of these that actually has the degrees in there too? Oh yeah, here we go. 120 degrees is 2 pi over 3. So let's see if we can finish those up. What is the sine of square root 3 over 2? So square root 3 over 2. What is the angle of x? Oh, that's just for the cosine. Oh, that's funny. So what is the angle of x when the sine is square root 3 over 2? Well, look, here it is. I wonder if I can just, oops, I was just going to try to copy that onto where we are so I could, okay, so this is saying what is the angle if the sine of that angle is the square root of 3 over 2? So look, here's the sine, the square root of 3 over 2, and it's at 60 degrees, but it is also at 120 degrees. So it is going to be both of those answers, right? It is both of those answers, because in both of those places, within one rotation, the sine is the square root of 3 over 2. So this next one is a little bit trickier because I have to take the square root of both sides first. So if I take the square root of both sides, what I get is, what is the sine x of the square root of 3? And what's the square root of 4? 2. Boom, you guys, it's the same exact answer. They were just trying to trick us. And what is the tangent? What is the angle if the tangent is -1? Well, if the tangent is -1, then I know that both the sine and the cosine have to be the same thing, but one is positive and one is negative. So where are the sine and cosine the same exact thing, but one is positive and one is negative? Well, that's right here. The point's the same, but x is negative there, y is positive. And here they're both negative. So here they are both the same thing, but this time the y is negative and the x is positive. So there are two answers to this one, 3 pi over 4 or 135 degrees. That's this one. And this angle down here is 315 degrees or, I can't really see that, 7 pi over 4. Yeah, that's right, 7 pi over 4, right there. So it's asking for the angle if it gives you the sides of a triangle, okay? Or if it gives you the sides of this on the unit circle. Do I have time? I might have time. What's next? What's next? Oh no, let's start this one, next one. I'm actually going to leave and go home before I get to this particular question, so you're going to have to wait a little bit for those to get on there. Oh man, I did not make this review, you guys, so do not blame me for how long it is. But just wait up later and I will get these for you.